we see the advantages of vertex form. If we're given the standard form for a quadratic function, ax squared plus bx plus c, the question is, how can we get it into this nice vertex form where we can read off the vertex hk and also have this a. That tells us about the graph of a function. Well, in fact, the a is the same in both of these equations. The goal here will be to take a function in this form and write it in vertex form. There are a couple of ways we can do that. One way is by the method of completing the square. So let's go ahead and work through this example. Find the vertex and the x-intercepts for this function, this quadratic function, x squared minus 2x minus 15. All right, so what we want to do is we want to take this and write it in the form a times x minus h squared plus k. All right, so we'll complete the square on the first two terms, like the minus 15 over here. All right, and the method for completing the square, to do that, we'll look at the term right here, this negative 2x, that's the linear term, x to the first power. We'll take the coefficient, the negative 2, and divide by 2. We divide by 2, we get 1, negative 1. Then we square it. So the procedure is to take negative 2, divide it by 2, and then square that. That gives us 1. That means we need to add 1 to complete the square. We can't just add 1 though. That changes the function. We can subtract 1 to balance things out. So net we've added 0. But this now completes the square. So our function, f of x, we can now write as x minus 1 squared, and this minus 1 goes with the negative 15 to be minus 16. So we've written the function x squared minus 2x minus 15 in this vertex form, where here we can read off all of the important information about this parabola. The a is 1. That means it opens up and has the same shape as x squared. The vertex is at 1 comma negative 16. Okay, completing the square is one way. There's another way we can find the vertex directly from the standard form, and that's using the vertex formula. The vertex formula says that the vertex for a quadratic function in this form is at the point negative b over 2a, comma, and then it would be the function evaluated at negative b over 2a. Let's use this vertex formula on what we've already looked at over here. We want negative b over 2a. B in this case is negative 2, and a is 1. So we'll have negative 2 over 2 times 1. And then we want the function evaluated at this, negative 2 over 2. All right, well, negative 2 over 2 is just 1. And then we want f of 1. And what is f of 1? F of 1 is going to be 1 squared minus 2 times 1 minus 15. So we have 1 minus 2, which is negative 1, minus 15 is minus 16. And that's what we got over here from the vertex form of the quadratic. So we found the vertex for this quadratic function, and now let's find the x-intercepts. The x-intercepts are where the outputs of this function are 0. So that just amounts to setting this function equal to 0 and then solving for x. We've done this when we solved quadratic equations. So we have 0 equals x squared minus 2x minus 15. And we can factor this, so we have x minus 5, x plus 3. It gives us x equals 5, and x equals negative 3. And so our x-intercepts are going to be 5, 0, and negative 3, 0.